Controlling relative humidity in cells can be a bit of a challenge, but it is similar to some of the mechanisms that Mother Nature uses already on the Earth. In our case, we actually take advantage of the relative humidity, dew point, and absolute humidity. Here in this CELSS or biosphere that I've created, I'm actually using a thermoelectric device. And what a thermoelectric device does, it actually is a device that is connected into two parts. It is by a silicon chip that you put current across it, and on one side you end up having it cold and the other side you have it hot. The way Mother Nature does it is by having Antarctica take and condense some of the water that's in the air and turning it into ice at one of the polar regions. So if you start with air that's at 10 degrees C with 1 gram of water evaporated into it, 1 cubic foot, keep the volume all the same, then raise it 10 degrees, it'll probably take about 2 grams. This is just for an example. Then you put 2 grams of water inside 1 cubic foot, 10 degrees higher. Then you reduce down back to 10 degrees less. You'll end up having a relative humidity that increases. So the amount of water that is contained for the density or the size is actually more dense. That means more water. The point where it turns from a vapor into actual water is called the dew point. Now you can calculate that using the relative humidity and as well as the temperature of the tank. This is done inside the tank and it controls the thermoelectric device when to turn on. Here's the trick. In order to be able to condense water from evaporated water into water itself that can be removed out of the air, there needs to be a thermal disconnect, a type of abrupt change in temperature. And so from the air to the thermoelectric device, or the long shaft that comes out of it that's cold, there's enough there that it triggers the water to condense and then turns into ice on top of the long extension of the... So one mechanism inside the biosphere is a control feedback loop. There is a hygrometer or a moisture sensing device that gives me relative humidity and temperature. From there I can calculate the dew point and I can calculate the absolute humidity. From there the feedback goes and turns on or off the thermoelectric device. So the evaporated water is then triggered into condensing on side of the rod and then turning into ice because it's relatively cold. The system here turns the thermoelectric device on for 45 minutes and then off for 15 minutes. This allows time for the ice collected around the rod to melt and then fall back into the biosphere.